All right, let's dive into a question that trips up a surprising number of Java developers. Is Java really a 100% object-oriented language? The answer isn't a simple yes or no. It's actually way more interesting than that. So let's break it down. And look, this isn't just some random piece of trivia. Getting this wrong can seriously cost you, especially when you're in a technical interview. Honestly, it's one of those fundamental concepts that really separates the pros from the rest.
So, what's the big myth? Well, you hear it all the time. Java is built on classes and objects, so of course it's 100% object oriented. And yeah, it sounds logical, right? But it's actually a massive oversimplification. Now, let's be super clear. Java is fantastic at supporting the big OOP concepts. We're talking inheritance, polymorphism, encapsulation, the whole shebang. It handles them beautifully. But here's the catch. Just because you support those ideas doesn't mean you are purely object-oriented. That's a whole other level. So to really get to the bottom of this, we need a standard. We need to agree on what a purely object-oriented language even is. So let's lay out the rules of the game. The definition is super strict, but it's also really simple. In a pure OOP language, absolutely everything is an object. No exceptions, no ifs, ands, or buts. Every piece of data, every number, every character is an object, and anything you do is a method you call on that object. Think of languages like Smalltalk. That's the gold standard we're talking about. We can pretty much boil this down to a simple 3-point checklist. Rule number 1, everything has to be an object. Rule 2, all your data is represented as objects. And rule 3, every single thing you do, every operation, happens by calling methods on those objects. If a language stumbles on even one of these, it's out. It fails the purity test. So, how does Java do? All right, it's time to put Java under the microscope. We're going to apply these rules and find the exact spot where its perfect object-oriented armor starts to crack. And believe it or not, it all comes down to one of the simplest lines of code you can write in Java, int x equals 10. Just ask yourself this one question. That little x we just made, is it an object? The answer is a big, fat, undeniable no. And that single no is the whole reason Java is not a purely object-oriented language. It breaks rule number 1 right out of the gate. Not everything is an object. So who are the offenders? Well, it's this lineup right here. Java's 8 primitive data types. We're talking int, float, boolean, all these guys. They are not objects. They don't have a class, they don't have methods you can call on them. They're just simple, raw values. Here's what that actually means when you're coding. If you declare a primitive int, a, you can't do something like a.toString. It just won't work. The compiler will yell at you because a isn't an object. But if you use the integer object instead, it works perfectly. This is the real-world consequence of breaking that first rule. Now, you might be thinking, wait, was this just a huge mistake by the people who created Java? Not at all. This was a 100% intentional, deliberate design decision. They chose performance over purity. So why on earth would they do that? One word, speed. Primitives are incredibly lightweight. They barely take up any memory, and they are lightning fast for the computer to work with. Imagine if every single number in a huge, complex calculation had to be a full-blown object with all that overhead. Java would slow to a crawl. And this is what really makes Java a kind of hybrid language. It's deeply object-oriented at its core, but it makes this super practical trade-off. It gives up a little bit of that ideological purity to gain a massive advantage in real-world, everyday performance. But the folks who made Java were smart about this. They didn't just create this gap and walk away. They built a clever bridge to connect the world of simple primitives with the world of complex objects, and they called them wrapper classes. So they created these things called wrapper classes. The idea is simple. For every single one of those 8 primitive types, there's a matching class, like integer for int or boolean for boolean. It basically takes that simple primitive value and wraps it up inside a real object. And this is the absolute key takeaway right here. Wrapper classes are an amazing fix. They let you treat those primitive values like objects whenever you need to, like when you're putting them in a list. But they are a workaround. They don't change the fundamental fact that primitives still exist in the language as non-objects. Okay, so we've gone through all the details, the whys and the hows. Now, let's package all of this up into the perfect polished answer that's going to make you look great in any technical interview. Here it is. This is the killer answer. It's direct, it names the exact problem, primitive data types, and then it even shows the solution, wrapper classes. This tells the interviewer you don't just know the what, you understand the why behind it all.
All right, let's lock this in one last time. Quick fire round. Does Java support OOP? Yes. Does it have primitives? Yes. Are those primitives objects? Nope. Are wrapper classes a good workaround? For sure. So the final verdict? Java is a strongly object-oriented language, but it is not a purely object-oriented language. Boom.
And that's really all there is to it. I hope this cleared things up for you. Now I've got a question for you. What other programming myths or really tricky concepts do you want us to break down next? Let us know down below. Thanks for watching.